Hello everyone and welcome to our project presentation. In this video, we will present our project for the BMIP 3563 Jigs and Feature course. Our team consisting of HENG, YEAP, MINGTAT, and myself, NAJWA, BINTI, MUZAMIL. Throughout this presentation, we will explain the engineering objectives, the design concept, the fabrication process, and the assembly of the drill jigs and the final outcome of the project. We hope this presentation provides a clear understanding of how the drill jig was designed and fabricated. Now, let's begin with the engineering objective. This project focuses on design and fabricating a precious drill jig for an aluminum alloy workpiece. The workpiece requires several machine operations, including pocket milling, drilling, reaming, and thread tapping. This process requires a correct position to achieve consistent machinery quality. Therefore, the main objective of this project is to design, model, fabricate, and assemble a drill jig that securely holds the workpiece, improve machinery accuracy, reduce setup time, and provide repeatable position throughout the manufacturing process. To achieve accurate position, our drill jig was designed using the 3-to-1 locating principle, which restricts all 6 degrees of freedom of the workpiece. The primary datum provides stable support, while the secondary and tertiary datum accurately position the workpiece to provide unnecessary movement. It is important to note that the 3 bottom pins shown in the figure are support pins, not locator pins. They provide stable support while the locating function is performed by the custom jigs and locating surface. By eliminating unwanted movement, the workpiece remains securely positioned, ensuring consistent machining accuracy and repeatable drilling results. This slide shows the 4 main systems incorporated into our drill jigs. The locating system positions the workpiece accurately before machining begins. The supporting system provides a rigid and stable foundation using the support body and support pin. The clamping system securely holds the workpiece using M8 bolt, while the guide system directs the drill accurately through the guide hole. Together, this system improves machining accuracy, stability, and repeatability throughout the drilling operation. This slide presents the main components used in the final drill jig assembly. The custom components include the support for the drill jigs, custom jigs, and 3 support pins, all manufactured for aluminum alloy. Standard components such as M8 and M6 have hex screw, T-slot screw, and nut are used to complete the assembly and provide secure clamping. Overall, the combination of custom parts and standard hardware produces a rigid, reliable, and easy to assemble drill jig for accurate machining.
Okay, so this is our concept for the jigs and fixture since our focus is on a simple conventional machining for on top only, so we do the support pin for all the sides and the bottom, and you can see it in our sketching. And on the top, we use the custom jigs and the drill jig to act as a clamp and a jig for the. Okay, so we start by cutting the block and then face milling it to make it flat and smooth for the raw stock. And after that, we do the pocket milling for the custom jig and the support block to remove the internal material to put the workpiece inside. And after that, we do drilling for the drill jig and the support block to put in the support pin. Okay, so as you can see, left one is our 3D design and the right one is our physical product. So it looks almost the same, but because the top is a custom jig, but the right one we didn't put the custom jig in yet.
In this session, I found the main design limitation during the assembly. That is, M8 clamping bolt could not be fully tightened. Because both of the jigs were threaded, this required perfect alignment between the threaded holes. However, due to machining tolerance, slight thread misalignment occurred and two components cannot fully clamp together. This is the thread misalignment. You can see the jig and workpiece didn't contact properly. Besides thread misalignment issue, we also find several design limitations after fabrication. The first issue was incomplete thread engagement. The selected M8 bolt was too longer than required. It made the bolt cannot fully engage the threaded holes. The longer screw was used cause cannot fully engage the blade. To overcome this issue, we intend to use the bolt with appropriate length. The second issue was poor tool accessibility. The spacing between the bolt were too small, make it difficult to tighten the bolt using a spanner. You can see the spacing between the bolt is too small, so this is not convenient to assembly. To overcome this issue, I intend to increase the distance between the mounting holes for assembly convenience. Finally, the M8 bolts were too oversized for our mock-up feature. We intend to use the M6 bolts to reduce space while still providing sufficient clamping force. Although our jigs successfully demonstrate the basic principle of locating, supporting, and clamping, therefore, several improvements would be necessary before applying this design in an industrial production environment. First, the aluminum guide hole should be replaced with a hardened press-fit bushing to improve drilling accuracy and wear resistance. Second, the M8 clamping bolt should be replaced with M6 bolts, together with increased spacing between the mounting holes to improve accessibility during assembly. Third, the upper clamping plate should be redesigned with clearer holes to eliminate thread misalignment and achieve uniform clamping. With this improvement, this jig would provide better assembly reliability, longer service life, and improved suitability for repeated industrial production.
Okay, so in nutshell, the project is successfully demonstrate that the practical application of 3-to-1 locating principle by bridging the gap between the CAD theory and the conventional machining reality. And the repeatable workpiece positioning can be achieved, and custom lattice machine pins perform flawlessly, and CATIA integration minimize the initial design errors, and the limitation discovered during assembly.